Descriptive measures for populations, use of samples. Population mean, mean of a variable. For a variable x, the mean of all possible observations for the entire population is called the population mean or the mean of variable x. It is denoted by mu sub x, or, when no confusion will arise, simply mu. For finite population, mu equals the sum of x sub I divided by n, where n is the population size. Example: compute the population mean height, mu. The heights in inches of the starting 5 players on a college basketball team are given below: 66, 70, 75, 74, 86. The formula that we want to use is the sum of the data, x sub I, divided by n, which is the sample size. First, we want to find n and the sum of x sub I. N is my sample size, that is the number of pieces of data, which is 5. The sum of my data, which is 66 plus 70 plus 75 plus 74 plus 86, is 371. So I want to divide 371 by 5, and my solution is 74.2. So the population mean equals 74.2. Population standard deviation, the standard deviation of a variable. For a variable x, the standard deviation of all possible observations for the entire population is called the population standard deviation, or the standard deviation of the variable x. It is denoted by sigma sub x, or, when no confusion will arise, simply sigma. For a finite population, the defining formula is sigma equals the square root of the sum of, in parentheses, x sub I minus mu, close parentheses squared, divided by n, where n is the population size. Example: compute the population standard deviation, sigma. The heights in inches of the starting 5 players on a college basketball team are given below: 66, 70, 75, 74, 86. We've already found the population mean, which equals 74.5. Now we want to find the standard deviation. To use the formula, we need a table where we have our data points for x, 66, 70, 75, 74, 86. Then we want to find x minus the population mean. Going to our calculator, our first step is to click the Stat button. We want one edit, press Enter. Then in L1, we want to type in our data. 66, Enter. 70, Enter. 75, Enter. 74, Enter. 86, Enter. Arrow over to L2, highlight L2, and what we want to do now is to take our data points and subtract the mean, which is 74.2. Our data is in L1. Second, 1 types in L1 minus 74.2, enter, and now we have each data point with the mean subtracted. Moving back to our table, we enter in that information. Now we want to square that data. Going back to our calculator, we arrow over to L3, then up. We want to square the numbers in L2, so second, 2, x squared, enter, and now we have our data points squared. Going back to our table, we can enter in our information. Now we're ready to use our formula, so we want to sum our data points for x sub I minus mu parentheses squared. So adding 67.24, 17.64, 0.64, 0.04, 139.24, we get 224.8. One option that we have in addition to just adding up the numbers is on our calculator. Second, Stat is the list menu. Arrow over to Math. Choose number 5, which is sum, and we want to sum up L3. Second, 3, enter, and we also get 224.8. The other thing that we need for our formula is n, which is 5. Substituting into our formula, we have the square root of 224.8 divided by 5. On our calculator, second, x squared gives us our square root, 224.8 divided by 5, because we are using the population standard deviation. Then enter, and we have 6.705. If we're rounding to one decimal place, we have 6.7 as our standard deviation. Computing formula for population standard deviation. The population standard deviation can be computed using the formula sigma equals the square root of the sum of x sub I squared divided by n minus the mean squared, where n is the population size. This is just another way to calculate your standard deviation for your population. Either formula will work. Example, obtain the following parameters. The following ages in years were obtained for the players on a basketball team. The ages in years we have are 24, 25, 30, 37, 23, 31, 23, 24, 26, 30, 28, 37, 23, 21. 21, 36, 25, 24, 23, 34, 24. We want to find A, the mean, B, the standard deviation, C, the median, D, the mode, E, the IQR. So the first step in finding these pieces of information will be to enter the data in our calculator. Once on our calculator, we want to go to Stat, 1 Edit. In L1, we want to type in our ages, 24, enter, 25, enter, 30, enter, 37, enter, 23, enter, 31, enter, 23, enter, 24, enter, 26, enter, 30, enter, 28, enter, 37, enter, 23, enter, 21, enter, 21, enter, 36, enter, 25, enter, 24, enter, 23, enter, 34, enter, 24, enter. Double checking our data, we should have 21 pieces of data, and I have 21 numbers. Now I am ready to calculate. We click on Stat, over to Calc, one variable statistics, press Enter. If it comes up with this menu, you want your one variable statistics list, L1, your frequency list should be blank. and then you arrow down to calculate and press enter. If your screen happens to look like this, then you can just press your enter key. Either way, we can see that our mean is 27.095. So our mean is mu equals 27.1. Going back to our calculator, we want the standard deviation. And since we're looking for the population standard deviation, we want to use sigma equals 5.098, which rounds to 5.1. So we have sigma equals 5.1. Next, we want to find the median. We want to arrow down until we see MED, which is 25. For this section, eta, which looks like an N to represent the median, and it equals 25. For the mode, we want the numbers that are mentioned the most, or most frequent. We have 24 4 times. We have 23 4 times. So our mode is 23 and 24. Lastly, we want to find the IQR. We need Q1 and Q3 for that. So looking at our calculator, want to arrow down again. Q3 is 30.5. Q1 is 23. The IQR equals 30.5 minus 23, which equals 7.5. Parameter and statistic. Parameter, a descriptive measure for a population. An example, average age of all people in the United States. So the parameter is the average age. Parameter and statistic. Statistic, a descriptive measure for a sample. An example would be the average age of people from a sample of 3 states. The average age is the statistic. Standardized variable. For a variable x, the variable z equals x minus the mean divided by the standard deviation is called the standardized version of x, or the standardized variable corresponding to the variable x. Z-score. For an observed value of a variable x, the corresponding value of the standardized variable z is called the z-score of the observation. The term standard score is often used instead of z-score. Example, find the standard version of x. Researchers collected information on the body parts of a new species of frog. The thumb length for a female frog has a mean of 5.76 millimeters and the standard deviation of 0.78 millimeters. Let x denote the thumb length for a female specimen. To find the standardized version of x, we want to find the z-score. Z equals the data point minus the mean divided by the standard deviation. To create the standardized version of x, we want to create a formula that we can substitute our data into. So we want to leave x alone and just replace the mean and the standard deviation with what they equal for this data set. So z will equal x minus 5.76 divided by 0.78. Now that we have this, we can go on to other examples where we use our data. Example, determine and interpret the z-scores for a thumb length of 5.9 millimeters. Round your answers to 2 decimal places. We want to use the standardized version of x, z equals x minus 5.76 divided by 0.78. And we want to replace x with 5.9. And then we want to do our calculations. Going to our calculator, when we type in our information, we start with parenthesis 5.9 minus 5.76, close parenthesis, divided by 0.78. We want the calculator to subtract before it divides. Enter, and we get 0.179487. So z equals 0.18. To interpret our solution, this is 0.18 standard deviations above the mean thumb length because it is a positive z-score. Example: determine and interpret the z-scores for a thumb length of 5.5 millimeters. Round your answer to 2 decimal places. Again, we're going to use our standardized version of x. Z equals x minus 5.76 divided by 0.78. Replacing x with 5.5, we are ready to calculate our answer. If I press second, then enter, it retypes what I just did. I can do that as many times as I want to get the calculation I want. I'm going to arrow to the right until I am over the 9. Then I'm going to type 5 and press enter. And I have negative 0.3 repeating. So z equals negative 0.33. This is 0.33 standard deviations below the mean thumb length because my z value is negative. To recap descriptive measures for populations, use of samples, the population mean is the mean of our population, indicated by the Greek letter mu. There are no differences in how the sample mean and the population mean are calculated. Population standard deviation is indicated by the Greek letter sigma. Unlike the sample standard deviation, the population standard deviation is divided by n. Parameter is a descriptive measure for the population. Statistic is a descriptive measure for a sample. Standardized variable is just the z-score formula with only the mean and standard deviation substituted. The z-score is found when we substitute a value for the data point x.